Hello and welcome to Picotti's class. In this lecture I'd like to talk about graphing functions, more specifically linear equations. So let's say I have a graph like so. Linear equations are going to follow a specific format. That format is y equals mx plus b. So the m is going to be your slope. And it's going to be equal to rise over run. And another way of saying that is it's going to be equal to the change in y over the change in x. By the way, in case you didn't know, this is going to be your x-axis and this is going to be your y-axis. Right? So the slope is equal to the change in the y values over the change in the x values, rise and run. So the other term you're going to need to know, the other variable, is going to be your b. And this is going to be your y-intercept. So let's work through some examples and it will make more sense. So our first equation, we have y equals 3x plus 3. This is our beautiful graph here. And this is going to be the x-axis and this is going to be the y-axis. And so the first thing we need to do if we want to graph this equation is identify the y-intercept. And in this case, it's going to be 3. So we go up 1, 2, 3. Let's put a green dot there. So that's going to be our y-intercept. And now we need to identify the slope. And in case you guessed it, it's also going to be 3. So the slope is the coefficient in front of the x term. Remember, slope is going to be your rise over run. And in this case, it's going to be 3 over 1 because our slope is 3. So starting from the y-intercept, we're going to go up 1, 2, 3, and over 1. So you can imagine our first coordinates are going to be there. And now we have to do it again if we want to graph this line. So I'm going to go up 1, 2, 3. You can imagine that the graph was larger. I'm going to go over 1 again. Whoops, not really sure what happened to the first one. It's somewhere like that. The second one will be somewhere over here. Whoops. So you can imagine we'll get a graph like so. And if we connect the dots, we'll have a line like that. And now this is a positive slope because we're going uphill, right? If it was negative slope, it would be going downhill. So keep that in mind as we work through some more examples. So in our second example, we have y equals 2x plus 4. What is going to be the y-intercept? That's right, I thought I heard it back there. It's going to be 4. So now we go 1, 2, 3, 4. I'm going to put a green dot at 4. At 4. Whoops, that's being funny. There we go. Awesome. So now the slope is going to be 2 because this is the coefficient in front of x. Slope is going to be equal to rise over run, or in this case, 2 over 1. So what that means is we're going to go up 2 and over 1, starting from our y-intercept. So we're going to go up 2 over 1. So that'll be our first point. And now we do it again. We're going to go up 2. I'm not sure what happened to the first point, but if we go up 2, 1, 2, and over 1, we'll be right there. keep doing it, go up to over 1. Right, so we'll have a line. If we play connect the dots, we'll have a line that goes like that. Exactly what I'm going to do. Well, it's not perfect, but you get the idea. So you would have a line that looks like so. Let's work another example. So in this equation we have y equals 5x minus 2. First thing we want to do is identify the y-intercept. In this case it's going to be negative 2. So I'm going to go to my graph, I'm going to go down 1, 2. That's going to be the y-intercept. So let's put a green dot there. And now we have to identify the slope. The slope is going to be the number in front of the x. Right? So it's going to be the coefficient in front of the x, which in this case is 1/5. Slope is equal to rise over run. Remember, rise is going to be 1 and run is going to be 5. So starting from our y-intercept, let's go up 1 and over 5. 1, 2, 3, 4, 5. So our first coordinate is going to be here. And now we have to do it again. So we're going to go up 1. This time we're right on the axis and we're going to go over 5. 1, 2, 3, 4, 5. So to graph the line, all we have to do is connect the dots. You'd have a line like so. Let's work another equation. So in this example, we have y equals negative 3x plus 5. Let's identify the y-intercept first. So that's going to be 5. So when we graph that, we're going to go 1, 2, 3, 4, 5. Let's put a green dot right there. Awesome. And now we have to identify the slope. In case you guessed it, it's going to be negative 3. So slope is equal to rise over run. The rise is going to be negative 3, and the run is going to be 1. So let's do it. We're going to go down 3. 1, 2, 3. And then we're going to go over 1. So it'd be right there. 1, 2, 3, 1, like right there. And then we have to continue the trend. We're going to go down 3. Whoops, don't really know what happened to our last coordinate. Just right here. And now if we continue the trend, we're going to go down 3, 1, 2, 3, and then over another one, 1. This doesn't look as pretty as what it would on graph paper, but you get the idea. So now we have to play connect the dots. Oops. It's a little too funky there. Let me play connect the dots. Alright, that's better. But you can tell it would be a downward, right? Like, so you can imagine running downhill because this is a negative slope. So as compared to all the other examples, they're running uphill on a positive slope. This is that one example where you would be going downhill on a negative slope.